Okay, occasionally you'll put this in the quadratic formula and something like this will happen. Uh, the ones we previously practiced, this would come out to be a perfect square, like something like the square root of 9, which is 3, square root of 36, which is 6. This one's kind of ugly because we don't know off the top of our head a number times itself that equals 40. So if this happens, what you're going to do is simplify this. Now remember, there's an invisible 2. If there's not a number there, there's always an invisible 2 there. We do a factor tree. 2 factors that get us to 40 other than 40 and 1. You could do 8 and 5 as well if you'd like, or 2 and 20, doesn't matter. And then these are all your prime numbers. You cannot break these down anymore. Remember, the 2 means find groups of 2 underlined. So there's groups of 2 right there. And whatever number is in the inside here, these turn into it. If you second guess that, just think of it like this. Square root of 2 times square root of 2 is square root of 4. And the square root of 4 is that right there, 2. These are left over, so you just bring those down. And then you're going to multiply those all across. That's going to give you 2 square root of 10. We're going to rewrite this now. What a lot of people want to do at this point is they want to try to reduce this to like 1/5 or reduce that to like 3/5. And the thing I always keep in mind is you cannot reduce unless this is a time sign. So if this was a time sign, you could in fact reduce that to a 1 and a 5, or you could reduce that to a 3 and a 5. It'd basically be your choice. But unfortunately that's not a time sign, so we got to kind of find a way around that rule. So there's a couple ways around this. One way you could do this is you could factor this out, meaning do the distributive property backwards. So let's think of this right here. So distributive property means we're going to need parentheses. We're going to find something that goes into both of these. In fact, we want to find the greatest common factor that goes into both 6 and 2, which is 2. 2 times 3 will give you that one. And we can just bring our positive and negative down if you want. You don't really have to think of the signs a whole lot here because both your bases are covered. We know that 2 times square root of 10, 2 times square root of 10 is going to give you 2 square root of 10. And I'm just going to basically drive down my positive and negative there. Now I just made it into a times problem. This 10, I'm going to rewrite it as 2 times 5 so that I can cross cancel. And then my final answer would be that right there. Now there is one other way we could do that. And this is how I would probably do it this way in most situations, to be totally honest. But if you circle this, you don't really have to think of this as an addition and subtraction problem. Remember me saying a while back when we were dealing with our T-chart rules that you could just look at these as positive and negatives as well. So I'm going to choose not to look at this as an addition subtraction problem. And another way we could do this is we could find what these are all divisible by, which is 2, and divide them all by that 2. So 6 divided by 2 is 3. 2 divided by 2 is 1. And 10 divided by 2 is 5. That's another way you could do it. And the last way you could do this is you could say 6 over 10 plus or minus 2 square root of 10 over 10. Is if you think about it, if they have the same denominator, when you add or subtract, you always get the same denominator. So that's why that rule works. Then you could just reduce that. And then you reduce that. And that is an acceptable answer, but sometimes the answer is asked to look like that as well. So it all depends on the instructions. That's it.